Okay, continuing on with the previous lecture, this slide at the end of the first video, it caught me by surprise. What they're trying to do here is teach you the present value interest factor by taking the present value at the end of at the first year would be 95, then taking that and dividing it by 105 to get the interest at the end of year two, and so forth and so on. In reality, it's easier to do what you see here, 1 divided by 1.05 to the fifth power, and it gives you an interest rate factor of 0.783526. However, in reality, you would take that normally it is done. You take $1 divided by 1.05, $1 divided by 1.05 to the squared value, that, and then you would have 1 divided by that, then you'd have 1 divided by 1.05 to the third power, 1 divided by to the fourth power, and finally 1 divided by to the fifth power. Now, if you were to calculate those values, you should get these values, 1.1 divided by 1.05 squared, and if you sum those up, they are the equal to 1 divided by 1.05 squared. I'm sorry, to the fifth power, excuse me. Now, if you multiply the $1,000, or the $1,000 that we had, $1,276 that we found earlier on, we were finding a future value, I believe. Yeah, right here, we were finding future value of $1,000 deposited today over 5 years. It would be worth $1,276 at the end of year, at time period 0, or today. Here we are looking at going the opposite way. It's saying that if you had if you received $1,276 in 5 years, it would be worth $1,000 today. And now the easiest way to do that would not be what they have here. It would be, and we'll talk about this in class, but it would be present value is equal to 1,276. Why am I getting things? .28 divided by 1.05 to the fifth power, and you should get $1,000 if you do that. Okay, now we will work some of these. We'll work multiple examples of these as we move forward in class. Now, here is the example of finding the future value based on $1,000 today over 5 years, no additional payment, 0 payments, at an annual rate of 5%. The future value is $1,276.28. Now that's how much it would be worth in 5 years. Now, if you want to discount it back, what would investors want? Would investors who want a 5% return favor $1,000 now or $1,276 in 5 years? Well, the answer is they would be indifferent, because those values are basically the same. But if they could buy the investment for $900 instead of $1,000, they would certainly want to do so, because they would earn a greater return than 5%. Now, if they were to pay $1,100 for it, they would earn less than 5%. We will work some of those problems out later on for you to see. If you were to take $900, take the $900 and multiply it by, let me see really quick if I can do this for you. If we were to have $900 today and we had a 5% return, 0.05, so you have the future value is equal to present value times 1 plus the interest rate to the nth power, whatever the period is. In our example, we've got plus $900 today, present value, times 1.05 to the fifth power, and you can see that is only a 1148. So in order for it to be $1,276, this interest rate would have to be higher. And let me just plug in that rate so that I don't have to. Okay, now you can see, but if I change that interest rate to 0.06, oh, it's more. And if I change it to 0.07, it's even greater. So you can see I would earn a 7% return if I could purchase that investment at $900. Now, if it were $1,100, I would earn less than the 5%. I'm not going to take time to do that right now, but we will work some in class. Okay, here's a practice problem you've been given. You've been offered an investment opportunity that is expected to generate $4,000 at the end of 3 years. So at the end of the third year, we are expected to get $4,000. Assume you earn a 10% return on investments of this type. What is the most you'd be willing to pay for this investment today? Well, that's a present value problem. You plug in the present value, you plug in the number of years, you plug in the future value, and as I have already told you, I always solve for the variable of interest last. So plug in 3, hit N, plug in I-10 and hit I/Y, plug in 0, hit payment, plug in 4,000, hit future value, and then hit CPT for compute present value, and you get $3,005. Here we're going to talk about the present value of an annuity. This is very much like a mortgage payment or a car payment, anything that you are paying on a regular basis. Here it's assuming that we get $1,276 per period over the next 5 years. Now here you've got the amount divided by 1.05, which is nothing but the present value. Present value is equal to future value of 1276 divided by 1 plus I to the first power. Here, 1276 in year 2 divided by 1.05 to the second power, because we're in year 2 now. In year 3, exponent is 3, so forth and so on. When you add up those 5 values, you get a value of 5525. So if I would be indifferent to receiving 5525 today or 1276.28 over the next 5 years, because either way I would expect to earn a 5% return. Here is the example of calculating the present value of an annuity on the calculator. 5N, because they're 5 years, interest rate is still 5% on an annual basis. The payment $1276.28, so it's 5 payments of this, and the value and the future value is 0. You compute present value, you get 5525.62, just as you do here. Now, one of the things that many people get confused about is like, why isn't the future value 1276? It's because we take that into account with the payment key. Payment 1, payment 2, payment 3, payment 4, payment 5. So we've already accounted for it using the payment key. So I receive this as payment 5, but there are no additional future values. So that is a bit confusing. We'll discuss it in class. Another practice problem, the value of a 20-year lease. Now this is real estate oriented, that pays 5% per year if you discount at 10%. The present value, now once again, they're just calculating it by hand using a table. 5,000 times the future value of an annuity of 8.51 gives you 42,000. We're going to use calculators. We're not using tables. You can see here we've got a $5,000 payment over 20 years, earning a 10% annual rate of return with no future value. Once again, the payment is calculated. The last value of 5,000 is captured in the payment, and you compute present value, you come up with $42,568. Present value of 4,000 at the end of each 4 years for 4 years. If your opportunity cost, your rate, the rate you have to earn is 10%. Well, once again, we have $4,000 for the payment, we have a future value of 0 because all payments are captured in these 4 years. We have an annual return of 10% required return to get a present value of $12,679. If you promise to pay $4,000 a year for 3 years, and your lender who expects a 10% return, what is the maximum amount that they would lend you today? Well, if you're going to have monthly payments or annual payments, I should say, in this example, annual payments of $4,000 every year for 30 years, and the lender requires a 10% return, the value that they would lend you today is $37,708. Once again, you would be indifferent to earning $37,708 today versus having 30 annual payments of $4,000. Here you have a real estate application of time value of money. They'd ask you to find the 6 different cash flows, the present value of them, that is, and the results. You've got $10,000 each year for 5 years, and then at the end of year 5 you have the $10,000, but you also have the you've got a lump sum of $100,000. View this as interest payments over 5 years, and view this $100,000 as a residual. You sell the property at the end of 5 years and you earn $100. We did similar examples to this in the discounted cash flow when we were trying to determine value. Calculator, now we've got 5 years, we've got 5 payments of $10,000, and we've earning an annual rate of 10%, and the future value is now $100,000, not 0, because we are actually having 5 payments and a residual value, or terminal value if you will, of $100,000. That equals $100,000 for present value. That's to say that you'd be willing to pay $100,000 today to receive $10,000 per year for 5 years, and at the end of 5 years the terminal value of $100,000. Evaluating a property with uneven cash flows. Now here we've got 48,000, 49,000, so forth and so on over the 5 years. They're all different. You can use the cash flow in your calculator to use this, or you can use a spreadsheet. I am not going to, we will go over this in class. I'm not going to go over it here, but I will point out for those of you who are interested, the cash flow keys are here on line 2, where you've got cash flow, net present value, internal rate of return, etc. if you are so inclined to work through that example. You would say 0 today because I'm not paying anything at time period 0, so that would be your cash flow at period 0 would be 0. Your cash flow at year 1 would be 48,000, cash flow at year 2 would be 49,000, so forth and so on, and you would solve for that, and you would find the present value, or really you would be calculating the NPV, and you would get 464,000. Once again, we will review this in class. The longer maturity makes present value more sensitive to the discount rate. If I've only got to wait 1 year to receive my money, it's much more likely that I understand the economy and the interest rates. However, for a 30-year note, which is the typical fixed rate mortgage is 30 years, there is a lot of uncertainty that's likely to go on between year period 0, the time at which the loan is generated, and the next 30 years. So you can see the farther out into the future you go, the more uncertain the cash flows will become. Once again, I'm not going to review this here. We will cover it in class, the internal rate of return. This really allows the investor to see a percent of return that they are expected based on some purchase price and some cash flows. We'll review this in class. Same thing here, and we will come back to these. Now, this is basically the capital asset pricing model. It says the expected return is equal to some risk-free rate plus some risk premium. We'll talk about risk premium in class, but generally for a mortgage, the largest risk premium is default risk. There is some interest rate risk because of the long period of time. There might be some liquidity risk, but we'll discuss more fully once we get into once I'm back in the classroom. Okay, that is the end of chapter 14. Once again, we were talking about the effects of time and risk on value. So I hope that you will review this. We will get into chapter 15 upon my return, which basically we will take what we've learned here in chapter 14 and apply it to some math. We'll look at calculating mortgages and payoffs and so forth and so on. If you have any questions, please feel free to reach out and let me know.